A very good morning, girls. I welcome to the online classes of the numerical analysis. And one thing I want to clear to you. So generally, see, in the questions they are asking about the rounding off. That means up to 3 decimals, up to 4 decimals they are asking. Girls, please don't confuse. Listen carefully. For example, I have the value for x1 is 2.82856. Okay, you can take like that also. If they mention in the question up to 3 decimals, then what you have to do? x1 equal to 2.828. After what do we have? 5. So if you have a 5 or greater than 5, then you have to take that it is 9. You have to add 1 to the previous number. Okay, that is 2.8 to 9. Clear? Next thing is nothing but here, this is nothing but the value of the x1. Clear? So next here, for example, you are taking the same value. There is no problem. And for example, after this one, I got that x2 is 2.8284, which is near value. And again next for the next iteration, 2.8284. Okay? Then you can stop the procedure and now you can take the 2.828. Okay? So now here, this is nothing but the procedure. If you want, then you can take it starting onwards. Otherwise, after calculating, after finding the root also, you can. Okay? So next here, write down actually we are discussing about the generalized Newton method, right? So in the generalized Newton method, I discussed one application which is nothing but x cube minus x square minus x plus 1, which is equal to 0, and here they choose that the value of the x0 is 0.8, right? So now here simply what I am doing is in that we consider the first value with p, after that without p, with p, without p, and so on, right? So now here after this one, actually here I am going to discuss one more application. I am not going to discuss that, just I am going to give homework to you. Okay? Write down. Find the root of the equation. Find the root of the equation. Sorry for that. Okay. Sorry. Find the root of the equation. You can say that it is a double root or normal root. Okay. X cube minus 5x. X cube minus 5x plus 3 equal to 0. Correct to 3 decimals. Correct to 3 decimals. By using Newton-Raphson method. By using Newton-Raphson method. Okay. So here simply now I am giving the hint to you. First of all, you have to take the equation and substitute the x equal to 0, x equal to 1. Then you will get one value is a positive and another one is negative. And after that, what you have to calculate f dash. So just take the formula xn equal to xn plus 1 equal to xn minus f of xn by f dash of xn. Okay, so then and so on, continue that procedure, and you will get that the value of the x naught is 0.5. Take those values now. x1 is 0.6471, x2 is 0.6566, x3 is 0.6566. Same value we have now. So you can stop the procedure, and they asked to find the root up to 3 decimals. So 0.656 is the required way. Okay. Next, using Newton-Raphson method. Using Newton-Raphson method, derive a formula. Derive a formula for finding the kth root of a positive number capital N, and hence compute the value of 25 whole to the power of 1 by 4. So firstly here what they asked, they asked to find the formula, and after that they are asking to find the value for the root for the 25 whole to the power of 1 by 4. Now write down, let capital N is a positive integer, let small x be the kth root of the number n, that is x equal to okay, so here I am going to take that the value is nothing but x is equal to kth root of root n. Okay, so now here x is equal to kth root of root n means we can write it as n power 1 by k, right? So now here x, if I am applying the whole to the power of k on both side, then what we get, x power k equal to n, right? So x power k is equal to n. So now here what I have that the value of the x power k. Now I am taking that the equation is nothing but x power k minus n is equal to 0. Now here we have to consider let f of x is equal to x power k minus n is equal to 0. Then what will be the value of the f dash of x? Derivative of x, that means k into x to the power of k minus 1 minus n is equal to 0. Where n is a positive integer, actually here you have to take it as a 0. Because it is a positive integer number, that's why it is nothing but 0. Now f dash of x is equal to k into x to the power of k minus 1. So then next here write down from the Newton's iterative method, what is the formula for the Newton's method? xn plus 1 equal to xn minus f of x by f dash of xn. Right? So now here I am going to take that simple thing as it is values, but I am going to substitute that f of xn and f dash of xn, because here we have f of x and f dash of x now. Now I am going to substitute this one. Now write it. Substituting above values in the formula, then we get see xn plus 1 equal to xn minus f of xn is xn power k minus n whole divided by k x power k minus 1. Of course here x is nothing but xn. Okay ma? So now this is nothing but the value. Now take the LCM. Then what we get here? xn into k into xn k minus 1 minus xn k minus n whole divided by k xn k minus 1. Okay, so now here k is constant. Xn into xn k minus 1, that means the bases are equal, power should be added. Now xn power 1 plus k minus 1. Next, minus xn k minus into minus plus n by k into xn k minus 1. Why I am solving this one now? Because they asked the formula. Right? So now here what do we have? K x n power 1 get cancelled. Now it is nothing but power k minus x n k plus n by k x n k minus 1. Okay, this is nothing but the required value of the x n plus 1. Clear? So now this is nothing but the value of the xn plus 1 I have. And now here still we can take that 1 by k outside. Okay, so when I am taking 1 by k outside, then what I am doing is I am taking xn power k is common. Then what we get? K minus 1 plus n by, here k is outside now. Now xn power k minus 1. Totally I have that the value of the xn plus 1 is nothing but 1 by k of, here what we have? K minus, now here what I am doing is k minus 1 into xn power k by xn power k minus 1 plus n by xn power k minus 1. Just I am splitting 1 by k of k minus 1. So here we have that xn power k. Okay, and in the denominator I have that xn power k minus 1. If I take to the numerator, it becomes xn power minus k minus 1. So then what we get, bases are equal, the power should be added, minus k plus 1. Both will be cancelled. We will get that only x plus n by xn k minus 1. So this is nothing but the formula. Okay. So simply first of all they asked about the formula, so that's why here I calculated this one. Next what they asked now? Derive a formula for finding the kth root of a positive number. Okay. So this is the formula. Next, and hence compute the value of 25 whole to the power of 1 by 4. 25 whole to the power of 1 by 4. Power is k. So now here k is equal to 1 by 4 and capital N is equal to 25. Now what we have to do? We have to substitute those values here. Then xn plus 1 and here what I get? 1 by k. 1 by 4 of k is 1 by 4 minus 1 of x plus 25 by xn. Okay, k is 1 by 4 minus 1. Now it is 4 of 1 by 4 minus 1 means 1 minus 4 minus 3 by 4 x. Okay, plus 25 by xn. 1 by 4 minus 1, 1 minus 4, that is minus 3 by 4. Okay, now 4 of minus 3x by 4 plus 25. Here we have minus 1, so I am taking to the numerator. Then xn whole power 3 by 4. This is nothing but the required value. Now what you have to do? You have to put that the value of the n is equal to 0, 1, 2, 3, 4 and so on. Okay? This is all. Now here for n equal to 0. Then what we get? x1 equal to 4 of minus 3x by 4 plus 25 x naught 3 by 4. Now for this one we have to know the value of the x. Actually here you can take that this value is also x naught. Okay, so now here see. Sorry, this is nothing but xn. Xn power k na. So when I am taking to the numerator, then it is xn. It is also xn, x0. Now I have to know what is the x naught. So now what I said, when we are taking the function, according to that one we have to substitute the values like a 0, 1, 2, 3, 4 and so on. Then you will get the interval. And for this application, write down the root lies between just wait ma. Oh shit. Here I said that k is equal to, okay. So I think you finished up to here, right? Now here write down where k is the root and capital N is positive number. Okay. Now write down. Now for the given value 25 whole to the power of 1 by 4. 25 whole to the power of 1 by 4. We have what is the number? Number is capital N equal to 25. Next the root is 4 not 1 by 4. Okay, already we mentioned that in the question itself it is a kth root. Okay, so that's why it is 4. Now here xn plus 1 equal to 1 by k means 1 by 4 of 4 minus 1 into xn plus 25 by xn 4 minus 1. 1 by 4 of 3xn plus 25 by xn cube. This is nothing but xn plus 1. Now for n equal to 0, then what we get? x1 equal to 1 by 4 of 3x naught plus 25 by x naught whole cube. We have to know the value of the x naught. That means we have to find that where the root value will lies. Okay, now what is the function? 25 whole to the power of 1 by 4. So now the meaning of that one is 4th root of 25. Right? You can write like this also. 4th root of 25. And write down this function lies between 2 and 3. If you want, then you can check. For one value you will get positive and another value you will get negative. Okay? So here the interval is 2, 3. So now here x naught equal to, you can pick that any value. Now what I said, you can take middle or you can take the starting value. Now x naught equal to 2. Now x1 equal to 1 by 4 of 3 into by x naught cube, that is 8. 1 by 4 of 6 plus 25 by 8. Now 1 by 4 of 48. Now 1 by 4 of 48 plus 2, 50, 53, 73 by 8. So now it is nothing but by using the calci, 73 divided by 32, 2.28125. This is nothing but x1 now. Next x2. What is the formula? 1 by 4 of 3x1 plus 25 by x1 cube. 1 by 4 of 3 into x1 is plus 25 by 2.28125 whole cube. What will be the value? 11.87185. 5, 6 I have, so I am taking 6. Now directly I am taking that 3 into 2.28125 plus open bracket 25 divided by 11.87186, close the bracket, and divided by, okay, now here it is 8.9495. 699 I have, I am taking 7. Now 8.9498957 divided by 4. Now it is 2.23739, so I am taking 74. See, the first digit is same, so the second digit is not same, so that's why you have to go for the next iteration. Next iteration means you have to find that x3, and for that you will get the value is x3 is 2.2361, and next again we have to go for x4. x4 you will get that it as 2.2361. Okay, so then you can stop the procedure. Next, write down ma. Next, after this one we have a Muller's method. Write down Muller's method. So I am going to give this Muller's method procedure in a step by step form. Then by that you can understand and you can remember easily. Okay, now Muller's method. And additionally there is a chance to ask that describe briefly about Muller's method. Alla kuda adugochandi. Okay. Now write down Muller's method is one of the technique involved in finding the root of the equation f of x equal to 0. This method is also used to compute complex roots. Complex roots means there is a chance to get the a plus ib form also. It is iterative and converges quadratically. Next item. Let the given function f of x is approximated by a quadratic curve, right in bracket second degree, in the neighborhood of a root. Next line. And assume the roots of a quadratic equation to be the approximations for the roots of the equation f of x equal to 0. Next slide. The steps involved in solving the root of an equation using Muller's method are as follows. Step 1. Write down clearly. Step 1. Let y equal to f of x. Y equal to f of x be a polynomial and xi minus 2 comma xi minus 1 comma xi be the approximations. Step 2. Consider any three distinct points on the curve y equal to f of x as what are the points? Xi minus 2 comma yi minus 2, xi minus 1 comma yi minus 1, xi comma yi. Okay. Step 3, write down. Using Lagrange's formula, obtain the second degree equation passing through the above 3 points. That is, now listen this formula, Lagrange's formula is denoted with L of x. Okay, now here first of all what you have to do, we have to take that the first point is xi minus 2. So that's why here what we have to do, we have to take that x minus xi minus 1 into x minus xi by ఏది ఇగ్నోర్ చేసాం, ఫస్ట్ వన్ అంటే xi minus 2 minus xi minus 1 into xi minus 2 minus xi. Okay, this is nothing but the about x values, and now here y I minus 2 functional value. Okay, plus ఇంకా ఉంది, కంప్లీట్ అవ్వలేదు. Here how many points? We have 3 points. Here we ignore the first point. That's why in the denominator we got xi minus 2 into yi minus. Now what we have to ignore this one. Then what we get? Compulsory x లో ఉండాలి numerator. X minus 2 into x minus xi by minus 2. ఇక్కడ ఏది వస్తే మళ్ళీ అది xi minus 1 minus xi into yi minus 1 plus x minus, last point we have to ignore. So xi minus 2 into x minus xi minus 1 by xi minus xi minus 2 xi minus xi minus 2 into yi by taking hi equal to xi minus 1 xi minus xi minus 1 and hi minus 1 equal to xi minus 1 minus xi minus 2 xi minus 1 minus xi minus 2. Then we get the above L of x above L of x as so generally here what I have, actually here we can write this x minus xi minus 1 can be written as like this. So please try to understand this one, ma. No need to write totally. Just for understanding purpose I am saying directly we can take the formula. So now here what I have, x minus xi plus xi minus. So this means can I write it as x minus xi plus hi? Yes or no? Yes. So like that. So now write down this value, and next x minus xi minus 2 means again x minus xi plus xi, and this one. Of course here we have that I minus 2, then we have what we have to do. It is x minus xi minus 1 equal to this one, x minus xi minus 2 equal to x minus xi minus 1 plus, just adding and subtracting with I minus 1 term, then x minus xi minus 1. Here what I have, of course here I am taking that x minus, h is nothing but xi minus 1 minus this one. So for this again we have to take another alteration, that is nothing but I don't, x minus xi minus 2 can be is equal to, right as it is equal to x minus same thing plus xi minus xi minus 2, which is equal to, again we have to take that x minus xi plus xi minus xi minus 2. Again we have to take it as x minus xi plus xi minus plus xi minus 1 minus xi minus 1 minus xi minus 2. From this we have to take the value, that is xi minus 1 minus this one. So then what we get, x minus xi into here xi minus 1 minus this one. That means here xi minus xi minus 1. The difference between these two is nothing but plus hi minus 1. Actually no need to remember all this, ma. What I am trying to do is I am going to write this entire formula in terms of the h also. Okay. So now similarly xi minus 2 minus xi minus 1 equal to minus hi minus 1 and delta I equal to yi minus yi plus 1. Okay, so these are the values, and I will continue this formula in the next class. So just we have to substitute all this in this formula, then we will get the L of x in terms of the h. Okay, so just you have to remember this formula, and now I am going to give another formula. Then simply by remembering those two we can solve the applications. Okay, we will continue in the next class. Thank you everyone.